We are talking about properties of rational exponents and radicals, and we're simplifying radical expressions. So here we have the cube root of 16 times the cube root of 4, and for each one of these is not going to work. But what we could do is we could try to rewrite these in a way that would make it so that we could take some things out of the radical. So one way we can rewrite the cube root of 16 is we can rewrite it as 4 squared. Cube root of 4 squared times the cube root of 4. And then if we have the same radical joined by multiplication, we can rewrite them under the radical. So we can write the cube root of 4 squared times 4. And we know that if there's not written there, then we know that it's exponent of 1. If we have the same base joined by multiplication, what we can do is just have one base and add the exponents. So 4 squared plus 1. And then we can say the cube root of 4 to the third. And we have the same exponent and the same radical. They cancel each other out, and the solution is 4. The next example, trying to find the simplest form. And what we want to try to do is we want to try to find a way to take 5 of something out of the radical. And we know this is an even number, so we can divide by 2. So the fifth root of 2 times 60. And then we can divide 60 again by 2. So the fifth root of 2 times 2 times 30. We can divide 30 by 2. So the fifth root of 2 times 2 times 2 times 15. We can divide 15 into 5 times 3, and that is as simple as it gets. 2 times 2 times 2 times 5 times 3. That's the most that we can get this broken down. We have 3 2's, we have 1 5 and 1 3, but we need 5 of the same in order to take it out of the radical. So actually the simplest form of this is what it was originally, which is the fifth root of 120. Another way we're trying to break 567 down is we can say 567 divided by 7. So in this case, we can say this is equal to the fourth root of 7 times 81. And we can either do one of two things. We can know that the fourth root of 81 is 3, or we can try to break 81 down further if we don't recognize that right off the bat. And so we can divide 81. We can divide that to 9 times 9. And we know that 9 can be broken down into 3 times 3. And 9 can be broken down times 3 times 3. And so now we have the fourth root, and we have 4 3's under the radical. So we can take those 3's out of the radical and put them in front as just 1. So 3 times the fourth root of 7, and then this is the simplest form. Last example that we have for this video We have 32 divided by 18 raised to the 0.25 power. The first thing that we want to do is we can divide 32 by 18, or excuse me, we can simplify this fraction, and that fraction gets simplified to 16 divided by 9. And we can write this because we know that another way to write 0.25 is 1/4. So we just kind of rewrote that and simplified it a little bit there. Now we can take the 1/4 and we can distribute it to the numerator and the denominator. And so we have the 4th root of 16 divided by the 4th root of 9. Now we know that the 4th root of 16 is 2, and we can't do the 4th root of 9, but we can break the 9 down, and we can say the 4th root of 3 times 3, or 3 squared. So we have 2 3's under the radical, but we need to get 4. So what we're going to need to do is we're going to need to multiply by 2 more. So we're going to multiply by the 4th root of 3 squared over the 4th root of 3 squared. Now, this is equal to 1, so we're not changing the value of this expression. We're just changing the way it looks. And so when we go to multiply this across, we get our final, or our simplified version. We get 2 times the 4th root. 9 squared is 9, so 2 times the 4th root of 9 divided by, now when we multiply this denominator together, we're going to get the 4th root of 3 to the 4th, and the 4 and the 4 cancel, and we're left with 3 in the denominator. And that is our simplified version.